Hello everyone. So we can now continue our discussion concerning this chapter, polynomial approximations and interpolations. So I ended up with this problem. So we're done with this problem. So this is the introduction to our topic, polynomial approximations and interpolations. So we now proceed with our main topic. So here's our so concerning interpolation formulas. No? Okay. So introduction to interpolation formulas. Okay. So interpolation formulas that I will introduce are very useful in approximating an actual function. No? For example, if we consider a graph, okay, let's say we have this graph. We have the points in the graph. Okay, let's say we measure the relationship between time and current. Okay, time and current. So for instance, that this is at time 0, the current is 0. Let's say at time 1 second, at time 2 seconds, okay, 3 seconds, and so forth. Then you measured, let's say this is 0.5 ampere, followed by 1 ampere, then followed by 1.5 ampere. Okay, for example, if at time 1 second, this is the corresponding current. Now, at time 1 second, 0.5 ampere. So let's say you did an experiment, and this is the experiment is that at time 1 second, it is 0.5 ampere. At time 2 seconds, the current becomes uh, 1.25 ampere, for example. Okay, so it becomes 1.25 ampere. Okay, so and then at time 3 seconds, it becomes 0.75. Okay, so 0.75. Okay, so this is now the graph, the plotted points. Okay, so of course you don't know the actual graph of the function, so you can just approximate that this is the curve. Okay, this is the approximated curve. Okay, so you can assume this is the approximated curve. Okay, so that is your assumption, no? From time 0 to time 3 seconds. Okay, so this is your approximating function. Okay, so that is your approximating function. So graph of the approximating function. Okay, wherein the function current as a function of time. Okay, so current as a function of time, where time is your independent variable. No, current is your dependent variable. Okay, so however, no, the actual function and the approximating function might not be the same. No? that is a greater chance, no? If, for example, you did the experiment at time 0.5 second, zero point 0.5 second, it's about 1 ampere. That's a possibility, right? Doing the actual experiment, it becomes 1 ampere. At time 1.5 seconds, it becomes 1.5 ampere. You don't know. So that's a possibility, right? Okay. So in that case, we can able to use interpolation formulas to approximate, no, the actual function. So the actual function graph may look like this, no? The actual function graph may look like this. Okay, there, no? That is a possibility because you did not consider all of the time uh time in this axis, no? From time 0 to time 3 seconds. Okay, so this is your, for example, this is your actual function. Okay, that's your actual function. Okay, so especially when doing your research has something to do with experiments, and you are to graph, no? You are to plot the points and make a graph, no? So of course you don't know, you cannot consider all of the time, no? Let's say from 0 to 10 seconds, no? uh, you you may also consider decimal numbers, no, between 0 to 10 seconds, no, in my example. So with that, no, so we'll use interpolation formulas to approximate the actual function, no, to approximate the actual function. So halimbawa, ito lang yung ginawa mong experiment. Hindi mo kinuhanan yung from 0.5, yung tapos 1.5, 1.25, 0, 1, 2, 3 lang. At ito yung lumitaw ng mga points. Yan. So that means, so pwede tayo mag-apply ng mga interpolation formulas, no, to approximate the actual function. No? To approximate the actual function. Okay. So let me continue. So one of the most important applications of finite differences. Okay, I already introduced finite differences in my previous discussion. So I'm referring here the divided differences, no? Divided differences of a function as well as differences of a function. Okay, and that's it. So one of the most important applications of finite differences is to determine, okay, approximated values of the actual function. No, approximated values of the actual function between consecutive tabular values of the independent variable. Okay, let me illustrate that. No, so for example, we have here uh, the interval 1 second, 2 seconds. Okay, so in my example, no, so we'll use finite differences to determine approximated values, no, of the actual function between consecutive tabular values. Let's say we have time, then we have the current. Okay, at time 1 second, at time 2 seconds. Okay, now at time 1 second, it's 0.5 ampere. At time 2 seconds, it becomes 0.75 ampere. Okay, so this is let's say 0. This is 1 ampere, for example. So this is 0.5, no? And that is 0.5. So this is 0.5. Okay, and then at time 2 seconds, 0.75. Okay, so it's there. So as you notice, we only have 2 points. Now considering those 2 points, we are to use interpolation formulas to approximate, no, the value of the actual function between 1 second and 2 seconds. For example, I'm interested in finding the value of the actual function at time 1.5 seconds. No, I did not do the experiment at time 1.5 seconds. I don't know. I did not do the experiment. Therefore, I will approximate the value of that current at time 1.5 seconds using interpolation formulas. No? So we have here consecutive tabular values. So we have time 1 second. So this is t sub 0 or t sub 1, t sub 2. No? T sub 1, t sub 2, I sub 1, I sub 2. So these are the consecutive tabular values of the independent variable. The independent variable here is t, which is time. No? Okay, so that is our goal, no, to determine approximated values of the actual function. Let's say at time 1.5 seconds, let's say it's 1 ampere using the interpolation formulas. Take note, no, interpolation formulas has something to do with finite differences. Okay, so that's why I introduced first finite differences, finding the divided differences of a function, as well as the differences of a function, because we will use those topics in uh, in our topic today, no? So which is interpolation formulas. So in here, let's say in our example, at time 1.5 seconds, it's about 1 ampere. This is your approximation using the interpolation formulas that I will introduce later. No? Okay? And this might be the graph. No? This might be the graph of the function. Okay? That's a possibility. Okay? It depends upon our computation. Okay? So we can proceed. Okay, so one of the most, okay na to. So hence, the actual function is replaced by an approximating function. Okay, so the actual function is replaced by an approximating function. Let's say, for example, let's say this is your this is your actual function. Okay, so this is the actual function, and then this is the, so we have the points. Okay, this is the sorry, So this is the actual function. We have the points. So at time 1 second, 2 seconds, 3 seconds. So these are the points. Okay. So let's say this is the reality. This is the actual function. Okay. Now you did the experiment. You did the experiment and using interpolation formulas, there's a possibility that you will arrive with this graph. That's a possibility that you will arrive with this graph. It depends upon the computation. Okay? So this is now your approximating function. Okay? So this is our goal to determine the approximating function of the actual function. Okay? So using interpolation formulas. And later on, we'll determine the equation of this approximating function after discussing interpolation formulas. Okay, so we can proceed. So consider the table shown considering x equals to 1 and x equals to 2. Okay, now the table does not provide data for all values of f between x equals to 1 and x equals to 2. So between x equals to 1 and x equals to 2, the table does not provide data, right? So let's say 1.5 na x. Between 1 and 4, ano yun kaya? 1.75 ba? 3 ba? 2 ba? Etc. Di ba? So it does not provide data for all values of f between x equals 1 and x equals to 2. So dyan papasok yung interpolation formulas para malaman natin ano yung approximated value ng function. Kasi yung actual function, di talaga natin malalaman yon unless you did the experiment. No? Unless you did the experiment, doon mo malalaman. No? So, in that case, thus we can able to obtain the values of f between x equals to 1 and x equals to 2 using finite differences. No? So, values ng f between x equals to 1 and x equals to 2. Dito, malalaman natin yan. No? Using finite differences. So, therefore, interpolation formulas. Kasi ang interpolation formulas, gumagamit ng finite differences. Okay. So, kung i-graph natin, yung function, f of x, ito yung kanyang, ito yung mga points. Okay? So, i-plot natin. So, this is now your approximating function, right? So, that's your approximating function. However, you don't know the actual function. Baka yung actual function pag ganyan pala. No? Okay? Basta dadaan sa lahat ng points. Posible, right? Baka ganyan yung actual function, right? So, we can proceed. In addition, we can also approximate the derivative, no, of the function at a particular point between x equals to 1 and x equals to 2. So, between x equals to 1 and x equals to 2, malalaman natin yung approximated derivative. Kasi, yung f of x na yan, using interpolation formulas, malalaman natin yung equation ng f of x. Okay? Na kung saan yung f of x na yon ay approximated function na siya. Hindi siya actual, no? Approximated. At from there, no, sa gitna ng dalawang value, let's say nandito yung point. Sa point na yan, malalaman natin yung derivative. Sa point na to, malalaman natin yung derivative using the approximating function na makukuha kapag ka ina-applyan natin ng finite differences, yung interpolation formulas natin, no? That I will introduce later. So, likewise, the integral of f over a particular range between x equals to 1 and x equals to 2 can also be approximated, no? Uh, so, halimbawa, no? Ang concern natin ay yung graph ay yung area x equals 2 hanggang x equals 4. Ano yung area na yan, no? Siyempre, meron kang approximating function. Let's say ganyan yung approximating function natin na makukuha natin kapag ginamitan natin ng interpolation formula. Okay? So, ma-approximate natin ngayon yung area. Malalaman na natin yung area ngayon. Okay? Yan. Yan yung gamit niya. So, sa chapter 5, yung ano na yan, yung topic na pagkuha ng area. Okay? So, sa pagkuha ng area, pag-aaralan natin yung trapezoidal rule and Simpson's rule, no? Sa chapter 4, derivative naman ang pag-aaralan natin. Kasi chapter 3 to. Okay? So, sa chapter 4, derivative. Sa chapter 5, area, yung integral, no? Integral yung pag-aaralan natin. Approximated value of the integral, no? Over a particular range, no? So we can proceed, no? So here are the interpolation formulas. The first one is the Newton's divided difference formula. The second is the Lagrange formula. The third is the forward Gregory-Newton interpolation formula. Last is the forward Newton-Gauss interpolation formula. Okay? So these are the interpolation formulas that I will introduce, no? So let's start with the Newton's divided difference formula. For Newton's divided difference formula, so to determine the equation and or value of the actual function at a particular point in its graph, okay, the Newton's divided difference formula can be applied. No? So, ito yung formula na yan. F of x equals to p as a function of x, no? Wherein n here denotes the degree of the polynomial. So, ibig sabihin niyan, this is a polynomial. Okay? Polynomial yung ating function. Okay? P as a function of x with to the nth degree, no? So, degree n yung ating polynomial. Okay? And then, so siguro naman alam niyo yung polynomial. So, that is in algebra, lesson in algebra. At siguro naman alam niyo rin yung degree of a polynomial. That is also a lesson in algebra. No? So, don't worry kung di nyo alam. Pagka nagkaroon tayong example, i-discuss ko pa yan in detail. No? So, in this case, r as a function of x, no? Considering, so yung r as a function of x na yon after n plus 1 terms. So, ito kasi ay yung nth degree polynomial na yan ay merong n plus 1 terms. Okay? So, halimbawa, x plus 1, 2 terms, di ba? Ano yung degree? First degree. X equals to 1, first degree. O, n is 1, 1 plus 1 terms, 2 terms. Okay? Let's say x squared minus 2x plus 1. Okay? Ano yung degree? Pag sinabing degree of a polynomial, yung highest degree, no? Doon sa polynomial, no? Pag sinabi kong degree, yung exponent, no? Yung highest degree nung variable. So we have 2. So we have 2. So we have n plus 1 terms, 2 plus 1 terms. So we have 3 terms, no? 3 terms. So first term, second term, third term, 3 terms, okay? Okay. So this is the actual function. Take note, this is the actual function. Okay? Now, this is the approximating function. This is the approximating function. So, yan ang goal natin. Hahanapin natin yan. Yung approximating function na yan. Ito ay error term. Yan ay error term. Ang tawag dyan ay error term. Okay? So, error term, yan yung remainder after n plus 1 terms. After n plus 1 terms. Remainder after n plus 1 terms. Kasi yung ating approximating function, meron siyang n plus 1 terms. Okay? Maximum of n plus 1 terms. Okay? Meron siyang maximum na n plus 1 terms. So, remainder after n plus 1 terms. So in this topic, no, magka-concentrate tayo dito. Approximating function. Pagkuha niyan, no? So, ito yung ating equation ng ating approximating function. Okay? At ang tawag ngayon dyan ay Newton's divided difference formula. No? Newton's divided difference formula. So, the approximating function can be obtained using the Newton's divided difference formula. So, this is the equation of the approximating function. The equation of the approximating function is obtained using the Newton's divided difference formula. And also, aside from obtaining the equation, we can also obtain the value of the actual function at a particular point in its graph. No? Okay? Let's say ang x natin ay 2. Okay? Substitute lang natin ito ng 2. Yan. Yan. Okay? So, malalaman na natin ang sagot nung function. So, kasi meron kang table, x, f of x. Let's say x sub 0, x sub 1. No? F of x sub 0, f of x sub 1. Meron kang x sub 0, nasa table na yan. x sub 1, meron ka rin. Yung f, yung divided differences, i-construct mo yung divided difference table, no? Para malaman natin yan. Divided difference table, construct natin para malaman natin yung second order divided differences, no? Itong f of x sub o, x sub 1, x sub 2. So later, we'll have an example to this to better understand. Okay? So, yun siya. So, actually, may pattern siya paano siya ma-memorize. So, we have f of xo plus x minus x sub o. Okay? Plus x minus x sub o times x minus x sub 1 multiplied by f of x sub o, x sub 1, x sub 2, and so forth. Hanggang makarating ka sa x minus x sub n minus 1 times f of x sub o, x sub 1 until x sub n. No? So, inuulit ko, ito is the approximating function ng Newton's divided difference formula. Ito yon. This is the Newton's divided difference formula. Yung f of x, no? Ito yung actual function ng Newton's divided difference formula. Okay? Ito yung approximating function ng Newton's divided difference formula. So sa topic natin, more on tayo doon sa approximating function ng Newton's divided difference formula. Okay? Yun ang gagamitin natin pag nag-solve. No? Itong error term, hindi na natin ano yan. Kasi ano yan eh, parang ano yan, kung in-experiment mo, dun malalaman yan. Yung function na yan. Kung ano talaga yan. Okay? So, in this case, this is the nth degree polynomial. So, this is a polynomial of nth degree. Okay? And then we have ito yung formula. Okay? Ng R. R as a function of x. So, x minus x sub o, x minus x sub 1, x minus x sub n times f times x sub o, x sub 1 until x sub n. No? So, this is the remainder after n plus 1 terms or simply error term. So, neglecting the error term, we can able to approximate the value of the actual function at a certain value x. No? Thus, f of x is approximated as p as a function of x. Okay? So, yun yung mangyayari ngayon. So, the actual function is approximated by this p as a function of x. So, let's answer a problem regarding this topic. So, we have neglecting the error term, use Newton's divided difference formula to find f of 5 from the following data. So, ito yung data natin, 4, 4.5, 5.5, 6, 7. And tapos ito yung mga f of x values. So, solution, okay, arrange muna natin sa ganito. So, they are arranged from lowest to highest in ascending order, 4 to 7. So, magiging XO, X1 hanggang X sub 4 yun. Okay. And then, we continue. We construct the difference table for divided differences of a function. Alam nyo na yan. No need to explain in detail kung paano gumawa niyan. Okay? Na-discuss ko na yan kung paano. So, in numerical form, no? uh, malalaman natin yung mga sagot dyan. Okay, alam nyo na to, di ba? Kung paano nangyari yan. So, using Newton's divided difference formula, no? So, ano ulit yon? F of x sub I, x sub j, no? That is f of x sub I minus f of x sub j over x sub I minus x sub j. Right? So, yun yung formula for Newton's, formula for divided differences of a function. Ito yung first order divided differences of a function. Okay, try nga natin. So, x sub I, f of x sub I, that is 1.58, 1.58740 minus 1.65096 over 4 minus 4.5. So, tapos makukuha mo sagot ay positive 0.12712. No? Positive 0.12712. Okay, no need to elaborate. Alam nyo na yan. Okay. So kung nakalimutan nyo to, go back to my previous discussion. No? So, then we have using Newton's divided difference formula. No? So, we have f of x is approximated as p as a function of x, where p as a function of x is f of xo plus x minus x sub o times f of x sub o x sub 1 plus x times x minus x sub o x minus x sub 1 f of x sub o x sub 1 x sub 2. See the pattern? So, meron siyang pattern, di ba? Una, f of xo, tapos x minus xo, madadagdagan ng x1. Ito. Tapos, madadagdagan ito ng x minus x1. Tapos, madadagdagan ito ng x2. And so forth. Ganun siya. Hanggang umabot ka dito. X minus x sub n minus 1 times f of x sub o x sub 1 hanggang x sub n. Ganun yung pattern, no? Okay. So, we have this. For n equals to 4 and x equals to 5, no? So, ito siya, no? For n equals to 4 and x equals to 5. So, ito kasi yung, consider muna natin yung n equals to 4. Okay? For n equals to 4, meron ka ditong nakikitang, so n equals to 4, sabihin hanggang x minus x sub 3. Kaya, dito yung limitation niya. X minus xo, x minus x1, x minus x2, x minus x3. Tapos, hanggang dito yung 4. X sub 4. Okay? Ganun ang pattern, no? So, una, f of xo. Tapos, madagdagan ng x1, madagdagan ng x2, dagdag ng x3, dagdag ng x4. Next pattern, x minus xo, x minus x, madadagdagan ng x minus x1, madadagdagan ng x minus x2, hanggang umabot ka ng x minus x sub 3. Okay? That's it. And then, substitute natin yung 5. Okay? Using the table, yung divided differences table. Divided difference table. So, ito yun. Alam na natin yung kung paano gamitin, right? So, substitute lang natin yung mga values at makukuha natin yung sagot. Ito. Ang sagot ay 1.70998. No? So, may x sub o sa table. Yung x, 5, di ba? Ayun. Yung x sub o ay 4 dun sa table. Sa table, yung f of x sub o, x sub 1 ay 0.12712. Sa table, yung f of x so x1, x2 ay negative 0.00861 and so forth. No? Then you will arrive with this answer, 1.70998. That's it. So here's the activity that you will answer now. So simulate the solution of the previous problem using Excel such that when the given 5 f of x values are changed, ito yon, a new correct value of f of 5 is obtained. Ito yon. So we can proceed, no? Allow me to share to you my Excel file. Ito siya. Setting problem, neglecting the error term. Use Newton's divided difference formula to find f of 5 from the following data. So, ito mismo yung gagawin niya. No? Yan yung gagawin niyo. So, kung mag-consider ka ng Newton's divided difference formula. Okay? Di naman mahirap yan. Tsaka meron na kayong guide, di ba? O, neglecting the error term, di ba? So, tapos, dito naglagay ako para guide ko. Let's say, x sub, ang k kasi lagi magsisimula ng 0. 0, 1, 2, 3, 4, di ba? O, 4, 4.5, 5.5, 6, 7. Ito yung nasa table. Tapos meron siyang value. Ito, guide ko yan. X sub A, X sub B. Kasi, ang pattern yan, dun sa table, x sub 0, x sub 1, tapos x sub 1, x sub 2. O kaya ganyan ang ginawa ko. 0, 1, 1, 2. 2, 3, 3, 4. Okay? So, tapos, second divided differences. Okay? So, ito ay 0, 1, 2. Followed by 1, 2, 3 dun sa table. Okay? So, pakita natin yung table. Ito. Ayan, di ba? Ayan. O, let's say, ito. 0, 1, 2. Di ba? O, A, B, C. 0, 1, 2. X sub O, X sub 1, X sub 2. Ito. Yan yung negative 0.008606667. Tapos, 1, 2, 3. Ito yun. X sub 1, X sub 2, X sub 3. Okay, ito yun naman to. X sub 2, X sub 3, X sub 4. Okay? Tapos, ayan. Hanggang umabot ka dito sa dulo. Okay. X sub 0, X sub 1, X sub 2, X sub 3, X sub 4. Ito. A, B, C, D, E. 0, 1, 2, 3, 4. X sub 0, X sub 1, X sub 2, X sub 3, X sub 4. So, yun. So, almost 0 yan. Times 10 to the negative 5. Diba? 0 yan. Okay. So, ganun siya. So, and then, so, syempre, alam nyo nang i-excel yan. Okay. So, n equals to 4. I'll give it, n is 4 degree polynomial. Okay. Ayan. So, halimbawa, meron ako dito nga 0, 1, 2, 3, 4. So, meron akong 5. Meron akong 5 data values. So, para malaman ko yung n, minus 1. Okay? Yun yung magiging degree ng aking polynomial, yung approximating function. Okay? 4. Tapos, itong 5, x equals 5, right? Ano yon? 1.70998. Ito. So, ito kasi, 5 decimal places siya, kung mapapansin nyo. Kasi nga, ni-round ko siya. Ni-round ko siya sa 5 decimal places. Round off 5 decimal places. Kaya, bibigay niya automatic ay 5 decimal places. Okay? So, ganun siya. So, I hope you get it. Correction lang, lab activity 10 siya. Okay? Okay, thank you. Good day, everyone.